Now, imagine Mount Everest flying through the vacuum of space at 20 times the speed of a rifle bullet. That is what was heading toward Earth. Now, when a rock that big hits a planet, it's going to be a bad day no matter what. But a bad day doesn't necessarily mean the end of 75% of all life on Earth. The Earth is huge. An impact will cause tsunamis, earthquakes, and a massive explosion, but life is surprisingly resilient. To cause a global mass extinction, you don't just need a big rock. You need a big rock to hit exactly the right spot. The asteroid struck the Yucatan Peninsula in modern-day Mexico. To a dinosaur, this was just a nice, sunny coastal property. But geologically speaking, it was a powder keg. This specific region was exceptionally rich in two things: hydrocarbons, which is basically organic matter and crude oil, and sulfate evaporites. In plain English, the asteroid didn't just hit solid rock. It hit the Earth's equivalent of a giant underground matchbox wrapped in dynamite. When the asteroid made impact, it instantly ignited and vaporized these materials. This ejected massive amounts of soot, sulfur, and fiery aerosols straight up into the stratosphere. This terrifying cocktail wrapped around the entire globe, acting like a giant, impenetrable blackout curtain. It blocked out the sun, stopped photosynthesis in its tracks, and plummeted global temperatures into a brutal, years-long winter. Here's where the math gets genuinely insulting if you're a dinosaur. Geologists have calculated that areas with enough of this specific, explosive, soot-producing rock to cause this level of global cooling covered only about 13% of the Earth's surface. Let that sink in. 87% of the Earth's surface was essentially a safe zone. If the asteroid had hit the deep Pacific Ocean, or literally almost anywhere else with low organic matter, there would have been massive local devastation. The coastal dinosaurs would have had a terrible afternoon, but the global climate change would have been much, much milder. The sun wouldn't have vanished for years, the plants wouldn't have died, the food web wouldn't have collapsed, and the dinosaurs likely would have survived. Imagine a giant cosmic dartboard. You blindfold the universe, spin it around 10 times, and it manages to throw a dart that perfectly hits the tiny 13% section labeled maximum global annihilation.